Okay, so another thing that we do with a fraction is we simplify it. So how do we simplify rational expressions? And let's go back, right? Let's look how we simplified something like 12 over 18. Now, back in the day, what we can get away with is magic tricks, right? Where, some of you are looking at this and saying, well, the common factor is 6. 6 goes into 12 twice, and 6 goes into 18 3 times, so I have 2 over 3. All right, and so that magic trick works really nice if you're familiar with your factors and numbers. But down here, right, it's definitely not going to work with 3, and it's not going to work with 4. And keep in mind, these things right now, right, those are all terms. And the way that we simplify a rational expression is we divide out common factors, right? Not terms. Terms are things that are involved in addition and subtractions. Factors that are involved in multiplications. So be careful, right? This x squared and x squared, they are common, but this is a term and this is a term, so I can't divide those out because there's that plus and minus around. So here's what happens. Let's go back to here. What's really going on is you're saying that 12 is 6 times 2. Notice I factored the number 12. 18, you're thinking, well, that's 6 times 3. And again, notice I factored the 18. Now I see that common factor of 6, right? So it divides out. 6 divided by 6 is 1. And we're left with the fraction 2 over 3. So that is the work actually going on. And that is going to help us over here. So you factor the top, you factor the bottom, and then you divide out common factors. All right? And so there's our work there. So starting off with number 1, again, since this is just one overall fraction, you guys have gotten very proficient. Perhaps you can just use the magic trick. But to be consistent, right, when I'm looking at between 12 and 64, I believe a 4 is in common, right? So we have 4 times 3, and then we have, if you really wanted to, we have x times x times x, right? And then 64, well, that's 4 times 16, and then we have an x. So you can start seeing, after I've broken everything up into a product, right, 4 divides in itself, and an x divides into itself, and upstairs what's left is a 3x squared, and down below is a 16. So again, you can probably do that in your head. We actually did that back in chapter 4 when we were talking about our exponential rules. So a lot of you can probably use that, but I'm just trying to, with this new idea of factoring the top and factoring the bottom, I'm just being consistent so we can get used to that. And so there's our simplification. Number 2, of course, back in chapter 4.8, we learned that we can break this up into 3 individual fractions and reduce each fraction. But to kind of demonstrate what we're doing here, I'm going to factor the top. So when I look at the top here, right, what seems to be in common, oops, I think I meant to put a x squared and an x there. Sorry about that. All right, so what I see in common is a 3 and an x. So I'm going to factor that 3x out, and what gets left behind is a 2x squared, right, minus x, and I think plus 3, right? And then we're dividing that. 6 is 2 times 3x. So again, I'm factoring the top and I'm factoring the bottom. I'm going to go ahead and stop here because that probably factors, but I can see the common factor right now is 3x. And so the top is 2x squared minus x plus 3 and all over 2. All right, so in this chapter 6.1, this is an acceptable answer. But, back in chapter 4, we probably even broke that down any further, right? So x over 2 and plus 3 halves, giving us x squared minus 1 half, right, plus 3 halves. So that's also an acceptable answer here. But I believe this is what, right, my math lab will ask you for in chapter 6. So kind of a little nuance there. We're still simplifying a rational expression by factoring the top, factoring the bottom, dividing out a common factor. Okay, so that kind of seemed like overkill for 1 and 2 because of previous chapter work, but we really need it for these next 2 examples. To simplify this fraction, I need to factor that trinomial, and I need to factor that trinomial, and then we spot to see if there's any common factors. Now again, I'm using the guess and check method. For those of you who use the AC method, use that. Either way, you got to get the top and bottom factor. And so the top, when I look at the top here, first times first is x times x, and then last times last, I believe a plus 3. Let me write that a little bigger. So x plus 3 and an x minus 1, I believe that works. So here's the check. First times first is first. Last times last is last. My outer is a negative x, and my inner is a positive 3x, giving us 2x. So I found the right factorization. On the bottom, first times first is 2x squared, so that's 2x and x. And then I believe for the bottom here, I think a 3 and a 1, make that plus and make that minus. So again, my check, first times first is first. Last times last is last. The outer is a negative 2x, and the inner is a positive 3x, giving me a positive x. All right, so again, you ACers would have taken a little bit more time getting there, but your factorization should be the same. And now that I have the top factored and I have the bottom factored, I can see that x minus 1 is a common factor. So we'll divide it out, and our final simplified answer for this is x plus 3 over 2x plus 3. And again, be careful. These 3's are not factors. Right now, because of the plus sign, they are terms. So we can't go any further, right? We only divide out common factors, not terms. So be careful. So last but not least, right, how do we simplify this fraction here? Well, again, we factor. Factor the top, factor the bottom, look for common factors. So how about I start with the bottom, because that's the difference of squares. So we have 2x plus 3 and 2x minus 3. So there's the difference of squares on the bottom. Upstairs, using my guessing and checking, I'm going to guess 2x times 2x. And then I think, how about we try a positive 3 and a minus 1. So first times first is first, right? Last times last is last. The outer is a positive 6, and the inner is a negative 2, giving us the positive 4. So I got it right. So the top has been factored, the bottom has been factored. So do you see any common factors? And I do, right? That 2x plus 3 and that 2x plus 3 are common. So what's left upstairs is 2x minus 1, and what's left downstairs is 2x minus 3. And again, careful. Yes, the 2x's are the same, but because they're involved in a subtraction, they're terms. And we do not divide out common terms. We divide out common factors. And so because they're not involved in a product, those are no longer factors. So that's basically our answer. So that is how we simplify rational expressions. You begin by factoring the top, factoring the bottom, and then you divide out your common factors, and that's it. All right, so more tougher examples coming up in the next video.